Hey everybody, good afternoon and welcome to Build. My name's Mike Hollinger, and it's my pleasure to walk you through how agents powered by NVIDIA AI Enterprise with Microsoft Azure can help unlock the next application that y'all will be building. Now, this is a photo of my husband David, our daughter Alexandra, and it's our trip to the zoo when I was visiting my parents over the holidays. And I want to share this with you because we'll use this photo a couple of times in this presentation. There's three things we're going to talk about today. First, context. It's something that's important to kind of pause and make sure we set as a group because things are changing so rapidly in the technology. Second, scale. What's it look like to put generative AI into practice and into production? And then finally, NVIDIA and Azure. How are we bringing the technology together? And how can you get started or get your next project to the finish line quicker? Now, I am a computer engineer by training, so I count from 0. So just work with me as a group here. I know it is afternoon. Tell me about the picture I just showed you. Just shout out. Family. Anybody else? Zoo. All right. Hieroglyphs. Yep. It's the Memphis Zoo. Elephant. Thank you. Wearing, sorry? Aquarium, yes. It's an aquarium as well. These are tokens. And you gave me back a stream of tokens just in a few moments. And chances are, your brain, as I gave you that prompt, was processing this image and trying to figure out what I was looking for, right? And you probably did a little bit more than what an agent or an LLM can do today, in that you probably imagined a story of how we got to that point in the zoo, wondered what we went and looked at. And that's part of what we're going to do today. We're going to talk about how this isn't just large language models today. These agent systems are about context. They're about judgment. They're about intent. And yes, tokens, but not just tokens. So context. I want to thank our partners, Microsoft. They've been putting together Build, and they've been a great partner for NVIDIA for quite some time. We heard from Kevin Scott this morning that he's asking everybody to go for something hard, something really hard. And see how far you can push the architecture. And we heard from Jensen and Satya's conversation during the keynote how we're bringing full stack acceleration to put into developers' hands. And this partnership is one that runs deep through all of this. Now, we're working to make AI tangible, and we're combining cutting-edge GPUs, model microservices, and orchestration layers. From hardware to runtimes to microservices, we've integrated fully optimized, ready-to-deploy foundation models into Azure AI Foundry for rapid enterprise-scale deployment. And from Azure ML to Kubernetes to Teams to 365 Copilot, the stack is production grade, and it's already powering intelligent agents in live environments. And the ecosystem that goes with this is vibrant. Enterprises, ISV, startups are building agents for everything from biopharma to telco to digital twins. And the tools are here, models are ready, and I want to show you how we partner with Microsoft to make agentic AI come to life in Azure. Now, this world is moving rapidly. In 2023, that was the year where open source innovation exploded. And we saw this proliferation of large language models in the community. I remember in November 2023 showing ChatGPT just to everybody, friends, family, colleagues, and being wowed as I started to converse with these systems for the first time, and in whole new ways. In 2024, some of us started talking about RAG, or Retrieval Augmented Generation. And we were seeing the first programming patterns emerge around the new tools. Enterprises were asking us, how do we ground these systems with my enterprise data? And now in 2025, this is the era of agents. Now, if you put yourself in someone's shoes, listening to these conversations, in 2023, we sounded like zookeepers. Llama 8B is misbehaving. I just pushed Falcon to staging. Have you seen Black Mamba? And in the context of the zoo, that'd be a little bit worrisome. In 2024, we sounded like librarians. We were citing references. We were looking for hallucinations and trying to eliminate flights of fancy and help these models to speak the source of truth in an enterprise. And now in 2025, we're managers. So for everybody here, this represents everyone in this room and at this conference, watching the stream at home as well. By show of hands, how many people are software developers here? Just raise your hand real quick. Anyone in customer success, customer service? How about researchers or students? Any lawyers? I promise not to make life hard or harder for you. Creators. Through all of this, agents are supporting each one of these roles. And the fundamental question is, how can I, as a knowledge worker, for example, become more productive and just make my life easier as I'm going about my day-to-day? So AI at scale is how I'm going to show you this. Our agentic AI platform is part of NVIDIA AI Enterprise. And really, I can describe that across 3 different vectors. First, full stack acceleration. From silicon to algorithms to middleware to microservices, we deliver the best economics for Gen AI workloads. It's enterprise grade. It meets security, stability, support standards. And it lets you focus on building your next app, not herding llamas. And finally, it's cloud native, and you can run it anywhere. From cloud to PC to bare metal to virtualized or Kubernetes, you can bring your workload to your data and not the other way around. Now, a year ago, NVIDIA introduced NIM to the world. What is a NIM? It's the fastest path to production. NVIDIA NIM microservices speed development with a choice of production-ready APIs and AI models, packaged in solutions that are readily accessible and with industry-standard APIs. They give you the best building blocks to start with for your AI solutions. And it's effectively an opinionated microservice. It lets you run a Gen AI model in the most efficient way possible. They're portable. You can run them anywhere. NIMs are easy to use. You can deploy them in just minutes. They are enterprise supported with updates, end-to-end testing, security, and they're performant. You get your choice of optimization for accuracy, for latency, for throughput, based on what your application is trying to do. We combine all of these: ease of use, operational simplicity, managed APIs, to give you the flexibility, security, and control to self-host however you like. And performance is probably the easiest and simplest thing to show as a value prop. If I run a Llama model on a GPU, I get great performance, yes. But if I run it via a NIM, I can get almost 2x throughput. And I'll show you a demo of what that looks like so you can feel it. So side by side, if I run the same model with and without a NIM, with the same prompt, you can just get a sense of what that feels like for the input and the output and the ability to work with the system. For every second I'm saving, I'm able to keep that person working in that inner loop. For every bit faster, I'm able to help get to that outcome quicker. And these NIMs streamline your path to production. There's well over 170 different APIs, 100 plus different NIMs, 40 plus different model types, and partners like Microsoft powering this innovation. And of course, we can run these wherever we need to, from Azure Container to AI Foundry to Kubernetes services to cloud instances or VMs. Now, I want to show you an example of this, and I'll flip over to my demo now. What I've got is a demo that I'm going to run 2 different ways, and I want to show you and let you feel for a minute some of the power of what we're offering. What I'm showcasing is a NIM for NVIDIA's Llama Nemotron model. I'll tell you more about that in a moment, but Nemotron is our reasoning model that's available. You can go try it out. You can download the NIM. You can see the data sets behind it. And I want to contrast it to a regular Llama model and let it try out a little bit of a logic puzzle here. So continuing with that photo, say we're at a wedding reception, and we need to seat 5 guests. There's constraints on those guests, and if you're like my husband, you love puzzles like this. He sits and does these all the time. But let's try this out with Llama without reasoning. And you can see it work through the problem step by step, and you can see that it actually does offer an answer. But did it get it right? Does anyone see a fault there? It should be, if we did this right. Oh, I did the wrong one. Aha, that's the trick. So it should be that I do this with the right order, the right dim. Let's try that again. There we go. I'll run that one and run this one. So this is our reasoning model here, and with reasoning visible and turned on, and this is the non-reasoning model. So we see Emily, Kate, Colin, Irene, Fred. And through this, if you kind of look at the output for a second, the model tried to work through it. It tried to show a valid answer, but it got it wrong. And that model did its best, right? You can kind of fiddle with it, mess with the prompt a little bit, and try to work through it. But a reasoning model does a lot better. And while I was talking, this one's been working through this issue step by step. You can try to count the number of weights as it double checks things, as it verifies and validates. But at the end of this, it's going to give us back Kate, Fred, Irene, Colin, Emily. And if I look back through the results, this should be the only valid seating that actually works, right? And it handled all the little tricky situations in my prompt about left to right and sitting next to each other from different perspectives. And it figured all that out as it worked through the issue. And the nice thing about this is that I can see the reasoning and understand it. And as a programmer, as a developer, I can work through this and trust the valid result that I got. So this reasoning that I showed you, this really I can break down into fundamental context, right? Does it understand the context of the problem? Does it understand how to combine together different bits of data? I'll show you a demo about that in a few minutes. Does it validate the answer? If you looked through that reasoning step, you could see it's double-checking things bit by bit along the way, and sometimes course-correcting. Did it handle ambiguity, right? I was asking about things from different perspectives, and it had to figure that out. And did it kind of roll with the punches there? If you look closely, there's just a bunch of little things that were referenced in that simple prompt of a few sentences. So this Nemotron model gives you the best of agentic reasoning. It's actually available in 3 different sizes: Llama Nemotron Nano, Super, and Ultra. Nano is optimized for PC or for edge, Super for high throughput data center GPUs, and Ultra for absolute best class accuracy on multi-GPU data center deployments. Each of these gives you the ability to toggle reasoning on and off. It gives you a way to get better time to value, time to market. They're open, and they're, of course, enterprise grade. Now, what makes this really kind of a top model? I mean, I showed you a toy demo, but their ability to deal with cause and effect, to link evidence to hypotheses, to justify rationale for what we're trying to do. Encoding tasks, those decomposition of requirements, writing correct code or debugging incorrect code. Mathematical reasoning. The toy example I gave you is kind of a form of this, right? But symbolic manipulation, pattern recognition, proof-style logic. Each of these benchmarks are benchmarks that we're really quite proud that Nemotron does well in. These cover domains like deductive logic, procedural planning, error correction, abstraction, which are really the essential competencies that you have to have for any AI agent in the real world. Now I want to take a small side journey for a second and talk about inference and inference at scale. When we talk about inference, any traditional inference system working on multiple GPUs, single GPU, really has two major bits of its workload, right? There's a prefill stage and effectively a decode stage. Now that prefill stage is compute bound, and it's doing a bunch of matrix multiplication. That memory bound stage is data moving around data. And that prefill phase is the one that's kind of dealing with that initial prompt from the user, right? I can try to measure that as a time to first token in terms of performance. In that decode phase, then we're dealing with all those other next tokens sequentially. And as we do that, we update the context with everything new that we've done so far, and we prefill each next new token. So I can measure that by intertoken latency. And if I start mixing these workloads, then I end up with suboptimal performance in the system. This brings us to this idea of disaggregated serving and allowing us to separate prefill and decode to get optimization that I can do much better for each of these independently. So I want to introduce to you NVIDIA Dynamo. Dynamo is an AI inference software stack. It's actually available open source on GitHub for reasoning at scale. And it's a successor to NVIDIA's Triton, and it builds on success in offering a new modular architecture designed to serve GenAI in multi-node distributed environments. I can scale inference workloads on GPU nodes and deal with dynamic allocation and respond to fluctuating demand as that workload changes and handle bottlenecks as needed. It supports TRT LLM, VLLM SGLang, and it incorporates the best-in-class and leading-edge inference optimization techniques such as disag serving, which separates the different phases into different GPUs. If I serve one of these models, like DeepSeek R1, on our latest GB200 NVL72 rack, which you saw a little bit of in the keynote earlier, with Dynamo using disaggregated serving, I can increase the number of requests by up to 30x. And it doubles throughput performance on something like a Llama 70B on our Hopper class GPUs as well. Use cases are things like serving reasoning models, helping to scale AI agents, distributed inference, or even code gen. So I want to just call out real quick, if you want to go to a hands-on session with Dynamo, scan either of the QR codes. There's a session later today at 3:45 and one on Wednesday at 4:30, where if you bring your own device, you can work with our experts and ask questions about how Dynamo works and learn about these different techniques and see how they work in the wild. So let me bring us to NVIDIA and Azure. So far, we've talked about tokens, and we've talked about reasoning and agentic systems, and I want to go from the what into the how. How is it that you can deploy and run these systems today on Azure? What we're showing with NIM running inside of Azure AI Foundry is a single platform that lets developers and IT teams discover, customize, optimize, and deploy models with enterprise-grade performance and governance. Now remember, NIMs are portable, they're easy to use, enterprise support, and they're performant. And with just a few clicks or a few lines of code, I can deploy them and spin them up in an optimized microservice using models from NVIDIA or the open community on your own enterprise stack. Now I want to shout out to our colleagues from the AI Foundry team. They have a session, I believe, tomorrow at 1:30 where you're going to see more about the great innovations happening from Azure AI Foundry. And whether you're using Azure ML, Kubernetes, or container apps, these services run on NVIDIA AI accelerated infrastructure. And every deployment includes AI enterprise support, and they're backed by the same stack that runs Fortune 100 data centers. So I want to show this to you. So I'm logged into AI Foundry, and just from the splash page, I can scroll down and see the model catalog. If I pop over to view the full catalog and search for the NVIDIA collection, I can see the 18 different NIMs that are available here today. This is one that's growing, by the way. These include everything from the 70B Llama model we talked about earlier to the Nemotron model that I gave you a double click on to just a few moments ago, to even models that are like our protein biopharma models. And all of these are available to help service and build out the next use cases that y'all are all trying to develop. If I pick Nemotron Super, I get to see all the information about the thing. I'll bump the font size up for you all. I can understand how it deploys, where it comes from, see details about the model, how to use it. And if I even want to, I can see the data set that comes as part of that. Deploying the system is simple. You can just choose a project. And if I deploy, just choose a shape, choose next. In this case, we have a 90-day trial, and then deploy, and the model starts to actually spin up. Now, I have this running already somewhere else, just to help with the demo, but I want to show you a deeper example of this reasoning model and show you some of the interactions of an agent and tool use and things like that. This demo is, by the way, based on the actual data from my husband and I's wedding. We asked our guests to please give us songs that they would like to hear as part of our playlist. So these are based on all that, so don't judge. But I'll upload the wedding playlist and give you a sense of it. But through here, our friends said, hey, we want to hear these things. And we love our friends, we love our family, but we also kind of vetoed a few things. And we marked a few that we have to prioritize as well. I'll go back to my little demo cheat sheet here. And the task is one that is maybe something y'all have tried to do. This is one where I want to manipulate the data. I want to make a playlist that ascends in terms of energy, which is one of the columns that's in my spreadsheet. I want to make it 10 songs long. It needs to start from a low energy song, move up to 5, drop back to a slow song from an artist we've never heard before, and go back up to 5 for a finale. Now, if I try this with our reasoning off, you'll see us go through, and what's happening under the covers, we're making an API call, and you can see the token streaming back. This is the model trying to work out how to actually write that code, and it's a live demo, so we'll see how this goes. Sometimes it figures it out, sometimes it doesn't. This didn't make it. But this is a non-reasoning model, right? What I find really interesting is that we asked for a description of the data, and you could see that it tried. It's described what it got, but it says, hey, there's a discrepancy. It asked for 10 songs, we got 14. It's kind of neat. And it tries to say, here's what happened as well. But this is kind of what you get with a system that is a single-shot model, right? Now, if I turn reasoning on, try the exact same prompt. Again, we'll kind of roll the dice here and see what happens. That model's now going to start working through how to actually solve this problem. And what you're seeing is an agent that's a code-writing agent try to figure out how to write Python. It's querying based on a sample of data, the shape of the data frame that's actually a pandas data frame in this case, and try to say, hey, so I know this is what it is. I know what my understanding of the challenge is. And it tries to break the problem down step by step. It obviously filters out the do not play songs, which is a good first step. And it tries to work through how it's going to actually approach meeting the challenge. What's kind of funny about this, though, is that you can see it follow different paths, see it work through the different scenarios, and explore. And it works through some of these kind of weird intricacies in the prompt as well. If I go back up, I told you a slow song is energy level 1 or 2, right? And I also told you I want to have 10 songs. And I also want everything to ascend in order, right, from energy. So it's possible to satisfy this and do it where I start from a slow song of 2 rather than 1, right? You kind of think about that. But it's going to break the model if I want only 10 songs and not 9 or not 11. And you can kind of see it work through this and understand how to try to break this issue down. In addition, I asked for not just don't give me a repeat for the slow song, right? I asked for don't give me an artist I've never heard before, which is, again, different. It's different data it has to track. And through all this, it's trying to work through how to actually make this go. Now, what's cool about this is that, in this case, the model actually tried some code, and it got a bug. You can see it try to work through that, and it's going to, again, try to figure out what went wrong, try to debug its own code, and try to reason about, hey, what should it do differently? And through all of this, I'm streaming tokens out of the system. You saw in the first attempt, it took us about 3,000 tokens to get to a not-so-great answer, right? In this case, we've had to think for quite a bit, and we're still trying to think. And the system's still trying to work through this issue, but it's working and making forward progress. And along the way, it's figuring out what it can figure out and learning what it can learn from its own thinking and processes. The funny thing about this is that this sort of tool use, this sort of reasoning is what's happening under the covers as you use any of these code assistants, right? And in fact, because this is a Chat Completions API, you can actually swap this out in your favorite IDE if you so chose, right? And along the way, it's learning and it's going and it's figured out something, and I guess we have to see if this is going to work here in a second. So at this point, we're now trying to actually run that code, and the system under the covers is going to try to analyze the results that came back. So we've now queried, and hey, we got our result. In this case, the first song comes up, 1 through 5, and we can see what the code looks like at the very, very end here as well. And the cool thing about this is that I was able to give it just a couple of sentences, right? And it worked through this kind of complicated issue. It worked through all the weird circuitous issues that came up with my prompt. It debugged its own code even and retried until it got to a valid answer. And the nice thing about this is, again, that this is something that's evolving and growing, and as we learn more as an industry, as we learn more as NVIDIA, we're able to update and to give out newer updates to this model as well. So I showed you earlier Nemotron, and it's available now as of today on Azure AI Foundry. So you can now take Azure AI Foundry, control your enterprise, and drop models from NVIDIA via NIM into these deployments and use them as part of the broader architecture that you're building out your next applications in. The example that I gave you is an example, I think, that's an excellent one of the different types of scaling that we're now seeing at play. Over the course of the last few years, we've seen pre-training scaling throwing more and more tokens at a given problem or a given pre-training data set. To post-training, we're working through alignment of the systems to help give just that extra little behavior bit that's going to make it that much smarter, to now test time scaling or that long thinking. We sat here for a couple minutes while the model worked through building out that answer for me. It took it about 15,000 tokens to get to an answer, right? Now, I've run this a couple of times, and it varies based on random seeds and all sorts of other stuff, right? But it takes anywhere from 6,000 to 15,000 to get to that result. And that wasn't even that tricky of a query, right? Imagine solving real actual software engineering bugs with real actual concurrency issues in a real actual large-scale code base. This is the importance of this reasoning system to be able to help you scale your effectiveness as not just an engineer, but as someone providing tools to your end users. So we've seen that we've gone from having larger models, and we've seen longer thinking times, we've seen larger context. We need more and more compute and next-level capabilities. Inference compute is really exploding, driven by these proliferation of large models, driven by the long thinking time that you need to work through these larger, more complex issues, and driven by the huge amount of data now available to you. Whether that's pulling data from an enterprise SharePoint or from other knowledge bases or from a code base, the millions of input tokens that are available now all are driving that extra context and extra capability for the system. Now, the integration of AI Enterprise and NeMo is not available not only through services like AI Foundry, but it's also available via NVIDIA's DGX Cloud. Now, DGX Cloud is a full-stack training platform that was co-engineered with Azure. The platform is fully managed directly from NVIDIA, and it includes AI Enterprise licenses, so developers can freely use NIM, NeMo, and the full suite of software for building and fine-tuning models. And critically, it also includes business support for NVIDIA Enterprise with 24/7 enterprise customer support and direct access to AI experts. DGX Cloud provides an AI factory to developers that are using Azure. And it makes it easy to access data for training, for fine-tuning, with tools and frameworks that we have through NeMo. And since DGX Cloud is running on Azure, you can easily use an AI factory on Azure Cloud to deploy and scale your applications. And your favorite services of choice are available to you, whether it's AI Foundry or AKS, and you can access your own fine-tuned model very easily. And of course, over time, you'll need to fine-tune your model as you collect more data and as you keep coming back through the flywheel that is the data flywheel to refine your model based on the thumbs ups or thumbs downs that you might be getting. So you'll need to come back to DGX Cloud to fine-tune and to refine that. So ultimately, the benefit boils down to the co-engineered best-in-class AI on best-in-class infrastructure. We've got different offerings for short and long-term GPU capacity, short as a month, as long as a year. And it's full stack managed by NVIDIA as well. And finally, it's NVIDIA AI Enterprise, so you don't need to worry about licensing when you're using it. Now, I want to talk more on enterprise grade, right? This is kind of the I think, crucial part of this. Our agentic AI platform is giving you a path to production, but you need to run this everywhere. This enterprise grade security, stability, manageability, and support are absolutely crucial. Security features like regular scans help ensure your data and your applications remain safe. The microservices and data science libraries are developer ready. They have API stability across updates. We patch them for security or for bug fixes. And we give you guidance for how to deploy these as well. So we make it easy to get up and running quickly. And of course, we support them, right? There's maintenance for the entire suite of solutions. If I pick just one of these containers, there's over 400 third-party packages in that container. Only 29 are NVIDIA packages. What we do is on the left. The value we're providing is on the right. We are maintaining and curating and fixing and optimizing this huge, complicated set of software. We're packaging it into a container, providing it along with an optimized runtime with that model to you as a developer, and from version to version, giving performance gains along the way. And we do these repeatedly through the life of the thing. So at a monthly cadence, you might actually see updates come out with new features or new performance benefits. And maintenance of this software stack is complicated. It really is. These containers encompass everything you need to run these models. And in that way, your developers aren't focused on fighting open source bugs, fighting dependencies. They're focused on solving problems in your line of business, in your domain. You know, we do this in a way that we work through all of the different internal dependencies so that we can maintain that upper level API so you all can depend on it. And we even offer different release cadences as well. And the production branches that I've been kind of alluding to through this whole thing, we hold stable across a 9-month life, released twice a year. There's an overlap between them. This gives you a solid foundation to work off of. It gives you a support statement you can provide to your customers and your partners as you're embedding the software into your own solutions. And of course, it pulls from the best in breed feature branches that we offer that are getting the latest innovations from all over, both NVIDIA and from our partners and from open source. But we're holding this stable as this foundational level, pun slightly intended, to give you the support you need. So across all these, we have different lifecycle options. We tie this to the different innovations, whether you want latest top of tree with the feature branches, that production stability, or even for those regulated industry workloads, we have a long-term support branch, things like for automotive or for heavy medical types of use cases. You can depend on us depending on which different path you want to follow along. And of course, we tie that back to the infrastructure layer that we tie to the GPUs and build out optimizations for our operators, for our drivers, and all the accoutrement that goes with that. Now, of course, we have to be able to run this software, and the cloud native point is one that's essential because users need to be able to run this, whether it's in Azure, whether it's on a PC with WSL, whether it's on their own hardware, bare metal or virtualized or with Kubernetes. We're optimized to run across all three of these through our work we've done with Microsoft and the great partnership that we have. So end to end, this software stack is really giving you everything you need from those core components, microservices, those models, even blueprints up above to help you build out your workloads. In fact, let me double-click on the blueprints just really briefly for a moment. A blueprint is a reference workflow. It's a specific pre-built use case that's obviously customizable. It's a starting point. That's why it's a blueprint. It gives you the reference code. It gives you everything you need to construct a workflow wrapped around the different NIM and NeMo microservices to combine with tools and documentation, get started quickly, riff off of what you have, what you need, and get to that production point much quicker. The collection of blueprints gives you everything for AI assistance, digital humans, customer service, enterprise, RAG, and some other cool ones that we'll announce soon. And you can obviously experience these either via NVIDIA's website or via AI Foundry. So let's really talk about this, right? If you want to see far more detail, my colleagues put together a great blog post that walks through exactly step-by-step how to get started with AI Foundry. It shows you screenshots and shows you videos, walks through how to deploy via the GUI or via code, and has all the reference material that I've shown in this presentation. You can also come by the NVIDIA booth. Feel free to ask us questions, double-click into conversations. If we don't know, we can grab some colleagues and get back to you. Basically, go out here, turn right at the Octocat, look for NVIDIA Green. You'll see us. The cool thing about this is that we get to have a conversation. And I think if I did this right, I have a little bit of time left for a Q&A. So with that said, if you'll have any questions, please grab a mic, and we can go through that.
It's maybe a very basic question, but what is a NIM-ready model? Like when you say you put NIM on a model, what does it actually mean?
Yeah, so great question. It's really a couple of different things. I'll go back to this point in the presentation, and I think it'll help me talk through it. Just give me one sec. There we go. The explosion that's shown here on the left really takes you from silicon all the way up to the microservice, exactly what's in a NIM. At the lowest level, it's CUDA. We're packaging the exact right CUDA for the hardware that you're running on. It's optimized with the right runtimes and the necessary accompanying operators or extra infrastructure necessary. If you're running virtual GPUs, support for that. If you're running on Kubernetes, bare metal, or anything in between. It also includes extra operational benefits, things to help with just the health checks of the system. There's a NIM operator that our colleagues have built out that can hook in and watch for and help with different issues surrounding that. And on top of that is the runtime environment, whether it's TensorRT LLM, VLLM, SGLang. We can build all this up, have an optimized version of that runtime engine, and then supply that to the open source model or closed source model, and give you an API on top. The complete thing from bottom to top is a co-optimized stack. You can obviously assemble this if you want, and lots of people do. My team is paid to do it. That's what a NIM is. Other questions?
The agentic demo that you were showing earlier regarding the wedding.
Yeah.
So was this just one model doing all the reasoning and the testing given the prompt? Or
Yes.
did you build a workflow in the background with two agents that work together?
No, it's actually, it's all one model. And the code's actually on GitHub. I'll should have put a link in the presentation. I'll do that. Ping me, I'll give you a link to it. My colleague Alex actually, by the way, wrote most of the code. He's going on paternity leave now, celebrating kid number 3, I believe, so congrats to him. But yeah, it's all one model. It's all that Llama Nemotron model. So when I showed you that toggle switch, right, that was toggling on in the initial API call whether we want reasoning mode on or off. It's the exact same thing under the covers. Behind that is actually 3 separate sets of prompts that are turning that model into an agent, effectively, right? One is trying to understand what is the intent of this user. Is it to build a graph? Is it to look at a data frame? Is it to answer a query? Another one is to write code to generate either a visual, or actually generate a code for visual, or generate code for given me data analysis. And finally, there's one that describes the output there. So when I showed you, here, when I showed you this explanation of key insights, this is a describer agent that did its best to explain what it saw given the context of the code that was given to it from the code agent, the output, and the prompt from the user. And you can see, like I said, right, that it tried. Right? This agent did its best given what it had. The code agent was given a prompt to write data, to write a piece of Python based on a data frame that came in and a shape of the data frame and some other context data. That's, I think, the first 3 rows out of however long of the data frame. And it just worked through it. In this case, it's calling into a tool which is trying to write and then execute. And the execution tool is trying to just interpret whatever came out of it. We, by the way, have a guardrails model that helps with that. But it's interpreting whatever came out of it. And based on either the success, failure, exceptions, or errors that came up, looking at the result, the code, and saying, OK, let's try again. And again, it's a little bit random here, somewhat on purpose. But I can see it kind of working through that under the covers and the logs. In fact, I'll show you that in my console here that was in the background. So all of this is one model given multiple prompts, given access to tools informed by some Python to solve the problem. And we wrapped it in the UI that you saw.
Thank you.
Of course. Other questions?
So VLLM is also a very popular LLM deployment framework out there. So how do you compare yourself NIM framework with VLLM?
VLLM is one of the deployment options we have. So VLLM, TensorRT LLM, and SGLang are the 3 that are available in NIM. And the cool thing about open source innovation is that we're seeing the rapid evolution of these different frameworks as we figured out how to squeeze every bit of performance. NVIDIA, through Dynamo, through Triton, through TensorRT, is bringing our perspective of the best optimizations. And we're going to support SGLang, support VLLM as one of the runtimes underneath there as well.
So NVIDIA has this set of tools around NeMo Curator, NeMo Evaluator, and many of these customization tools for any fine-tuning task, for instance, right? Let's say if we want to customize a model between a reasoning and a non-reasoning model, do you have any thoughts or ideas around how much data does it typically take in order to get a strong result, and you change the direction in which the base model was originally trained on?
Oh my gosh, actually, I have no point of reference on that one to try to build reasoning into the system. let me corner you afterward. We'll go chat with one of my colleagues. Our colleagues that are running the Dynamo sessions, I think, probably will be able to help with that. And one thing I touched on briefly, if you want to see it, you can get to from our AI Foundry link. Oh, I need to share my screen, don't I? Give me just a sec and I'll do that. So you can see from this link the data set that went into building Nemotron reasoning. And the data set's out on Hugging Face. You can use it to explore. To be honest, I don't know, but we can find out. Other questions?
Yeah, I can't remember which slide it was, but it went through almost like the entire platform or stack of all the NVIDIA tools, and it mentioned Run AI was coming soon. I didn't know if you could explain any of that, of how that's going to fit into the platform.
Sure. So I have a colleague that's joined us here, and I'm pointing a little bit, but the slide you're talking about is the DGX Cloud integration. Let me bring that back up, and I can go into that. I think it's right around probably here.
I'd like you to come to our booth after. We could chat.
Okay, fair enough. Sorry. Okay, so for everybody here, thank you so much. I invite y'all to please come engage with us, to ask us questions. NVIDIA is bringing full stack co-optimized acceleration from silicon to software. We're doing that to help create this ecosystem, to help create this next generation of shift in technology. And it's one that we're really proud of. Really proud of the work that our team has done, and we're even prouder of the work that our partners, our customers are doing with this as they go and build the next things. So if you have any questions about this, please reach out to me or to my colleagues. Come join us at the NVIDIA booth. Like I said, it's out here and to the right. You can come to a bunch of different sessions that are hands-on. You can learn about the technology. You can get started on tinkering. But my challenge to you, just as you heard from this morning, is to actually build something, to give it a try, to see what happens, to see how you might be pleasantly surprised. To be honest, when I built the demo for this, I was kind of halfway chuckling to see if I could make it work just for fun. It turns out that it did. These are the kinds of things that wouldn't be possible a year ago. And I look forward to seeing what you all build out over the coming year. So with that, thank you so much. And thanks to our Microsoft colleagues for the work that they've done as well. Cheers.